Hello everybody, my name is Paolo di Tommaso. I'm a research engineer in the Notre Dame Lab, the Center for Genomic Regulation in Barcelona. Um, Before I start, let me say that I'm very happy to be here. I would like to say thank you to the organization for giving me this opportunity to introduce you this work that is Nextflow. Nextflow is a framework and a domain-specific language that we've developed to simplify writing parallel pipelines in a portable manner. When we started this project a couple of years ago, the idea was to make it possible to fast prototype a complex workflow without having to learn a new programming language, but following the so-called Unix philosophy in which you can compose small tools to get a bigger program. So by composition at the end. But at the same time, we wanted to have a high-level prioritization model that simplified a complex interaction between the task and the workflow. It also enables make it possible to our script to be portable across different platforms. Maybe you develop in the laptop that you want to run a workstation or in a cluster computer or even the cloud. So to enable scalability, also to enable reproducibility of your pipeline in an easy way. And the idea is that your pipeline flow is defined in the collaborative manner. Your script is a composition of several processes, where a process represents a stage, a step in your pipeline, and then is defined by giving a set of inputs, a set of outputs, and a script fragment that has to be executed to carry out your task. So it's very easy. A process looks like something like this. There is the process name, then you can declare, maybe here, you can declare an input, in this case just a string, there can be many, and you say that you're expecting an output, in this case a file, and then there is the script that you want to execute that takes this variable that you define here, then capture the file that you specify this way. So this is something that is available also in other tools like SnakeMake or bpipe, if you know. But what is different in this case in our approach is that Nextflow is based on a reactive programming model that is called DATAFLOW. The DATAFLOW term is used in different contexts with different meaning, but in this case, we are referring to a declarative computational model for concurrent task execution. And this paradigm, this model, all your tasks, all your processes are parallel implicitly by default. You don't have to say that something is sequential, something else is parallel. And what they do, they just wait for data. When there is an input, the input triggers the execution of the task. Also, this process communicates by using data flow variables that are at the end, logically, you can think like a synchronous stream of data, and we call these variable channels. So what you get is that the parallelization, the task dependencies, are implicitly defined by the process input up declaration. You don't have to do much more. And so your pipeline is something like this. You can think like a network of reactive processes, all of them run in parallel. And when there is an input, this input triggers the execution. One task produces an output. The output will trigger the execution of downstream tasks. So this is the idea. And this will simplify the writing complex pipeline when you have many task interaction, because all of this is managed by the framework. And so this is a trivial example. There is just a single process that executes a BOSC query. We say that we need a file that we want to call sec.fa. This file is taken from a channel that we declare here. It's a channel that will emit the sequence file that is declared like a parameter. Then we can specify the script, the BOSC command. We are using this same file that we declare here. Then when execute the BOSC will emit the result that is redirected to this file that we have declared like the output that we are expecting. So it's captured forward into this channel that at the end is printed here. So this is the idea. You can have many of these processes. And to execute this, you use your terminal, your shell. Nextflow is a a small runtime, you say Nextflow run the script name, and you see it will execute the BOSC processes, it print out the BOSC output. So that's very easy. But what if you want to execute this with many sequence files, many queries? Since we declared that we have a query parameter, we can specify this parameter on the command line, maybe specify multiple files, and you will get your process executed multiple times, as many times there are files that match this wildcard. So this is the idea. You don't have to say execute this one or more time. All processes are executed by the data that you provide. And how to make your script portable across this way. How to make it possible the script to work in different platforms. By default, we run the script using a local executor that submit the job spawning Unix processes at the end. But since Nextflow there is a little abstraction layer that allows you to write your script for multiple platforms, by setting a configuration option, you can execute the same using a grid executor that will submit the jobs to a cluster infrastructure or even the cloud. We are supporting this platform, Grid Engine, Univa Grid Engine, LSF, Torque, SLAR, PBS, so the most used computing platform. Maybe there is still missing the support for Condor, but we are also supporting a couple cloud platforms that are DNA, Nexus, and Cluster Key. Then, how to make reproducibility easier? Here, the real question is, why it's so hard to deploy a pipeline different computational scenario in an easy way to repeat your result? Well, we know the problems. One of them is that pipeline script rarely is just a single script, but you have many dependencies. There can be external scripts, binary tools, database, web services. All of this stuff need to be configured in the hosting environment. Also, your script need to be updated frequently. So you need to track the changes, the version, and so on, and other problems. Our solution was to manage a pipeline as a self-contained GitHub repository. So the idea is that you try to consolidate your project without any external dependencies. So, including all external scripts that you may need into the repository itself, including the environment configuration, then the binary dependencies can be deployed with a Docker container that is associated to the pipeline execution. So, what we get is that a GitHub repository can be used to deploy a self-contained pipeline project in a consistent manner, different platform. And to explain better this idea, take in consideration that you have a project like this that you are shared on GitHub, or maybe somebody else shared into GitHub or on other sharing platform. And to run this stuff, you should clone the repository, then install all the dependencies, in this case the RNSA pipeline that we developed in this approach. So you should install, I don't know, cufflinks, topat, etc. But a much easier way would be that you just know the repository name. That's enough, because I could say, okay, Nextflow run using that repository name and eventually with Docker. In this case, what happens is that the very first time that you execute your pipeline, automatically it will download the repository in a centralized directory stored there, also download the Docker container, so you get your pipeline executed. By default also, it includes an example dataset, so you can run all this stuff with a single click. And what is interesting also to know that we are not running, using this approach, you are not running all the pipeline into a single container instance, but each step, each process execute its own container. By doing that, you are able also to distribute this execution in a cluster computer. Each job run its own container that is able to pull the dependency into all nodes in your cluster in a cloud environment. This is a terrific way to deploy your dependencies for your pipeline in an automatic manner. And few words about versioning, how to keep track of the history, the changes in your code. Here the idea is very easy. We just use any GitHub branch as a revision in our pipeline execution. So at any point you can switch to a different version, just specifying a GitHub, yes, that you use in your repository. For example, you could say, okay, run this pipeline using the revision 1.0, 2.0, etc. And it is very nice because the pipeline is consistent, because it brings within with itself all the scripts, the configuration, and also the binary that you use in that version. Yep. So just few words about with Nextflow. There is a small community of people. I will take the opportunity to say thank you to all these guys that give me a lot of feedback, contribution, idea how to develop these tools. And future work, we are testing a built-in low latency cluster that would allow us to run our computation in a more efficient way, particularly for short-lived tasks. In the middle term, I suppose in this winter, at the beginning of next year, we would like to add the support for BioBoxes project that is going to be introduced later in this session, and the support for the Git large file search. That is very interesting extension to Git, that because it allows you to store in a repository not only the code but real big data, large data sets. Also the support for Rugged containers, alternate implementation for containers technology. In the long term, we would like to have a graphical editor to be able to compose our workflow even easier way, and the support for a common workflow language that would be really useful, and eventually other clustering technology like Yarn, Spark, eventually Mesos. So that's all. These are some links if you're interested. Thank you very much for your attention.